All right, let's look at the homework 5.2, 5.3, problem number 5. All right, let's evaluate this indefinite integral. All right, so I'm going to use a substitution. I'm going to let u be this guy right here, so the expression inside the parentheses. All right, so we have 5 plus x squared. All right. And then usual drills, take the derivative u with respect to x. You would get derivative of 5 is 0, derivative of x squared would be 2x. And then we can take the reciprocal of both sides, so you have a dx over du, which is equal to 1 over 2x. And then since we want to isolate dx, we're going to multiply both sides by du. So dx is equivalent to du over 2x. All right, so let's rewrite this integral here. So this is equal to integral. So I'm going to leave 6x at 6x for now, 6x here, and over, all right, here's a u, and you have to raise it to the third power. Right, and then we have a dx. dx is equivalent to du over 2x, so we can plug that in here. So we're going to have du over 2x. Right, luckily we can cancel 2x and 6x, and you're leaving 3 on top. Right, so if you clean it up, you're going to get this. So we'll have an integral, and 3 is there. Right, so you have an over u cubed, so it's going to be u to the negative 3 power. Right, then you have a du. Right, and then we can find antiderivative using a power rule. So 3 is just a number, put it there. And then add 1 to the power, so it's going to be negative 2, and divide by that power. So you have to put negative 2 on the bottom too. And then plus some constant c. Right, then we can clean it up. We're going to have, so there's a negative sign, 3 on top and 2 on the bottom. And also, u is going to be on the bottom. Maybe I'm going to put the u on the bottom, and which used to be 5 plus x squared. And then you have to raise it to the second power. All right, then you have a plus c. All right, so let's type it in. All right, so we have negative 3 over 2 quantity 5 plus x squared and squared plus some constant c. Right, and it also says that the check by differentiating. So all you have to do is take the derivative of this result to see if you get this integrand here. All right, but let's check the answer. All right, I came back, and looks like we got this one correctly. All right, so I'm going to do the checking too. So here, so all you have to do is we're going to go backward. We're going to take the derivative of what we have here. So it's a negative 3 over 2 quantity 5 plus x squared quantity squared plus c. All right, so first thing I would do is I'm going to rewrite it because it's not in a very nice format. So you have a d over dx. It looks nice, but it's hard to take the derivative. All right, so negative 3 halves is just a number. But I'm going to write the 5 plus x squared to the negative 2 power because it's sitting on the bottom, and plus some constant c. All right, now I can take the derivative. All right, so negative 3 halves is just a constant multiple, so leave it there. All right, so here, so put the negative 2 in front, and keep whatever we have inside the parentheses, and subtract 1 from the power, so it's negative 3. then multiply by derivative of inside, which is 5x squared, so its derivative would be 2x. So I'm going to put 2x. And derivative of c is 0 because c is a constant. All right, so let's clean this up. All right, so we can cancel. There's a 2 on top and 2 on the bottom. We can cancel that. And there's a double negative, so this negative sign cancel out. Then what you get is going to be, all right, so this is going to be, all right, 3 times 2 is 6. All right, so since it's a negative power, I'm going to put the 5 plus x squared on the bottom, but we still have to cube it. Right? So you can see that we get exactly the same thing as the integrand here. So it's integrand here. So that verifies that this antiderivative is correct. Right? That's it. I hope that this was clear.